Hi everyone. In this session, we have to study the third module of Basic Electronics and Communication, that is Embedded System. In this embedded system, we have to study one by one. First one is definition of the embedded system and the difference between the general purpose system and the embedded system and classification of embedded system and the few applications of embedded system. Okay, now we have to study one by one. First one is definition of the embedded system. What is the definition of or what is embedded system? Okay. An embedded system is an electronic or electromechanical system designed to perform a specific function. What is embedded system? It is an electronic or electromechanical. Electromechanical means it contains some of the mechanical components, and electronic means the number of electronic devices embedded in this. Okay, and then it is designed to perform specific function. It performs only specific function only, not all the functions. Okay, this is what the embedded system. Now understood, embedded system is a electronic or electromechanical system designed to perform only some specific function, and then it is the combination of hardware and firmware. Firmware means it is software. This embedded system is the combination of hardware and software. And some examples of these embedded systems are in automobiles we are using the embedded system, and in some communication purpose, and in important example is in digital camera and aeroplanes and printers. These are the some examples for the embedded system. Okay, next one is, next we have to study difference between the general purpose system and the embedded system. First one is this general purpose system example is computer. Computer is the best example for the general purpose system, and for embedded system camera is the camera or calculator are the best example for the embedded system. Now we have to see what is the difference between the general purpose system and the embedded system. You have to remember the example. The example for the general purpose system is computer, and example for the embedded system is calculator, camera. Okay. First one difference is, in general purpose system, a system which is combination of generic hardware and generic purpose operating system for executing a variety of application. What? In general purpose system, it will perform all general functions, but in the embedded system what happens, it embedded system only performs only specific function. Okay, the hardware will perform the only specific function. Okay, and next second difference is, this general purpose system contain a general purpose operating system, that is GPOS, but in the embedded system it may contain, may or may not be the OS. The embedded system may be contain the operating system or not, but in general purpose system it contains the GPOS, that is general purpose operating system. Next difference is, next application is, in general purpose system applications are alterable. Means what? We can change the application, that is it is alterable. But in the embedded system, the firmware means the software of the embedded system is pre-programmed, that is it is not alterable. It is already pre-programmed, means it is not alterable. Okay. Fourth difference is, performance is the key deciding factor on the selection of the system. Always faster is better. The performance of the general purpose system is better. Performance means its ability, or it is faster. Okay, but in the embedded system, application specific requirements. it is depends on the applications, whatever the application requirements, that is dependent on the system. In the embedded system, that is power requirements or memory usage, these are, but it is general purpose, it is faster, but it is in the embedded system, it is application specific requirement. The performance depends on the whatever the applications are required, like power requirements, memory. Okay. Next difference is less or not at all tailored towards reduced operating power requirements, options for different levels of power management. This general purpose system will manage the powers in different levels of power management, but it is less, but in the highly tailored but in the embedded system it is highly tailored to take advantage of the power saving modes supported by the hardware and the operating system. In the embedded system, the operating systems will support the power saving requirement, but in the general purpose it is less. It is different levels of power management will occur in general purpose system. Okay. Next and last difference is response requirements are not time critical. In the general purpose system, the time requirement is not critical, but in the embedded system it is critical. Okay. For certain category of embedded system like mission critical system, the response time required is highly critical. In the embedded system, it is the time requirement is highly critical, but in the general purpose system it is less critical, or time requirement is not time critical. Okay. Next, go for the classification of embedded system. The classification is based on the what we are using in the mobile phone first generation, second generation, up to 5G, 4G level we are reached now. Like that they are classified the embedded system. The based on generation, there are 4 different generations. First one is first generation, second generation, and third generation, fourth generation. And based on complexity, they are classified as small scale embedded system, medium scale embedded system, large scale embedded system. Now we have to study one by one. Based on generation, the first generation is, in the first generation, the earlier first generation embedded systems were built 8-bit microprocessor like 8085 and Z80 and 4-bit microcontroller. In the first generation, they are using the 8-bit microprocessor and the 4-bit microcontroller. And the next point is embedded system possesses simple hardware and firmware developed assembly code. In the first generation, simple hardware plus software is embedded in that. The codes are in hardware plus software. And the next point is digital, and the examples for the first generations are digital telephone keypads, stepper motor controller units are example for this first generation. What we are using in the first generation? 8-bit microprocessor and 4-bit microcontroller. Okay. Next, go for the second generation. In the second generation, what they are using? 16-bit microprocessor and 8-bit microcontroller. And they are powerful and complex compared to the previous generation. Compared to first generation, the second generation is more powerful. And the example for this second generation is SCADA. That is, SCADA full form is supervisory control and data acquisition. And it is also, this second generation is used in the data acquisition system. Data acquisition system means it is how much data is required to acquire the system. It is called data acquisition system. It is one of the example for the second generation. Next, go for the third generation. In the third generation, they are using the 32-bit microprocessor and 16-bit microcontroller. Hence, the operation has become much more powerful and complex than the second generation. Compared to second generation, the third generation will be more powerful. Okay. And the example for this third generations are, it is used in robotics, individual processor controller. In the processor, they are using the third generation, and embedded networking. In the networking system, they are using the third generation. Okay. In third generation, what we are using? 32-bit microprocessor and the 16-bit microcontroller. The complexity will increases compared to second generation. Next, go for the fourth generation. In the fourth generation, they are using the processor and multi-core processor and core processor. Okay, what they are using in the fourth generation? Microprocessor and microcontroller as in evolved during these modern days. New concept like system on chip, that is SOS. SOS means SOC means system on chip, and system on chip and other multi-core processor also used in this fourth generation, that is microprocessor, microcontroller, and with these they are also using the system on chip and other core processors, and in this also complexity will be increases and it is more powerful. Okay. These systems also make use of the high performance real time operating system. This generation system will use the high performance and real time operating system. It is used in the real time operating system. Next, go for the next classification, that is it is based on the complexity of the embedded system. They are, first one is small scale embedded system. Small scale embedded system means it is less complex compared to the other one. Okay. In the small scale embedded systems are built with a single 8 or 16-bit processor or controller. The main programming tool used are an editor, assembler, cross assembler, and the integrated development environment. The IDE tools are used in the small scale embedded system, and 8 or 16-bit microprocessor or microcontroller are used in this small scale embedded system, and the hardware and software complexity in small scale embedded system is very low. Okay. It may or may not control the operating system for functioning because it is small scale. Okay. The best example for the small scale embedded system is electronic toy. It is example for the small scale embedded system. Next embedded system is medium scale embedded system. Medium scale means it is more powerful compared to the small scale. It is medium, not high, not low. Okay. The embedded system with medium performance, 16-bit or 32-bit microprocessor or controller or ASCII codes or DSP fall under the medium scale embedded system. In the medium scale embedded system, 16-bit or 32-bit microprocessor or microcontroller are used in this medium scale embedded system, and the ASCII or DSP digital signal processing tools are used in this medium scale embedded system. Okay. Next, they have both hardware and software complexities. In the medium scale, the hardware and software complexity will be there, and the main programming tools used are, the programming tools used in the medium scale embedded systems are C, C++, Java, Visual C++ and RTOS means real-time operating system, and debugger, source code or engineering tool or simulator or IDE tools. These are the tools, programming tools which are used in the medium scale embedded system. Next, go for the large scale embedded system. In the large scale embedded system, have highly complex hardware and software built around 32-bit or 64-bit processor or controller. In the large scale embedded system, they are using the 32-bit or 64-bit microprocessor or microcontroller because the complexity will be increased, and they are using the RISC processor, reduced instruction set. Okay, RISC processor, and SoC means system on chip, and scalable and configurable processor. They are also called sophisticated embedded system. Sophisticated means it is complexity is more in the large scale embedded system. They are used for cutting edges applications that need hardware and the software co-design where components have to be assembled into the final system. They also contain a high performance real-time operating system for task scheduling, prioritization and management. Okay, what they are all using, that is RISC and the SoC all are used in the large scale embedded system because the complexity of the system size more in the large scale embedded system. Okay, compared to medium, it is the complexity will be increased in the large scale embedded system. Okay, next go for the some of the major application of the embedded system where we are using the embedded system. First one is consumer electronics. In the camcorders and cameras, we are using the camcorder means it is video recorder. In that we are using the embedded system. Next in the household appliances, television, DVD players, washing machine, fridge and micro ovens. These are all household appliances we are using the embedded system. And home automation and security system. In the security system, in like air conditioner, sprinklers, introducer detection alarms. Detection alarms means where siren will detect the introducer detection detect the which will detect the anything, it is using for detection. Okay, and closed circuit television cameras, fire alarms, you know all the fire alarms, okay, etc. These are all security system. These are you using for security system. In that system we are using the embedded system. Next, automotive industry. In automotive industry, anti-clock braking system, that is ABC, and engine control, ignition systems and automatic navigation system. Okay, in these all we are using the embedded system. In telecom we are using in the cellular telephones, telephone switches, handset multimedia applications, etc. Okay, in the computer peripherals we are using in the printers, scanners, fax machine, etc. In the computer printer we are all using the embedded system. Next, in the computer networking system, networking routers, switches, hubs, firewalls. Networking routers means which will connect to form a network. They are called networking routers, and switches, hubs and firewall. These are all comes under computer networking system. Next, in the healthcare we are using embedded system as in the ECG and double EG. This is come under healthcare. And next in the measurement and instrumentation, it is in the digital multimeters and digital CROs which are we are using in the laboratories. In the lab experiment we are using the CROs, cathode ray oscillators, CRO means cathode ray oscillator, and logic analyzers, PLC systems. Okay, these are in the measurement and instrumentation. Okay, next in the banking and retailer sector, automation teller machine means ATMs and currency counters, point of sales, POS. Okay, this is comes under banking section. And in the card readers, that is barcode, smart card readers, and handheld devices, etc., that is RF readers also use the embedded system. These are the major examples for the major applications for the embedded system. Okay, thank you.